Hello everyone, welcome to Homework Help. If you find the videos useful, please subscribe to the channel. So in this video, we'll use the first derivative test to solve this word problem. So as per the problem, the concentration C of a drug in the blood T hours after the drug is taken orally is given by C at T equals 5T over 2T squared plus 7. And we have to find when does the concentration reach its maximum value. So we have to find the time at which this C function reaches its maximum value. So for that, we'll have to find the derivative of this function to find the critical point. So that's the first step. So critical points are points where the derivative is equal to 0 or undefined. So let's start by finding the derivative of this concentration function. Now this function is a rational function, so we will use quotient rule to find its derivative. So the first step is, so prime of C at T equals, so now we'll find derivative using the quotient rule. So we start with the derivative of the numerator, which is 5 times the denominator 2t squared plus 7 minus the numerator times the derivative of the denominator, which is 4t plus 0 over the square of the denominator. Now we have to simplify this expression. So we can simplify the numerator. So prime of C at T equals, so in the first part we'll distribute the 5 to the parentheses. So we'll get 10 T squared plus 35. And now in the second parentheses, so 4t plus 0 is just 4t. So we have to do 5 times 4. So we get negative 20t squared over 2t squared plus 7 squared. Now we can simplify the numerator by combining like terms. So we can combine 10t squared and negative 20t squared, and we get negative 10t squared plus 35 over 2t squared plus 7 squared. Now in order to find the critical points, we have to set this derivative expression equal to 0 and solve for t. Now for critical points, the derivative should be equal to 0 or undefined at the values of the independent variable, which is the t variable. Now this expression cannot be undefined for any t value because no t value will make the denominator equal to 0. So in this case, we can only analyze this derivative by finding the critical points at which the derivative becomes equal to 0. So that's why we just set it equal to 0 and then solve for t. So the first step is to cross multiply the denominator, and from that we get negative 10 t squared plus 35 equal 0, because 0 times denominator is equal to 0. Now we have to isolate t in this equation, so we should subtract 35 from both sides. So the 35 on the left side will cancel each other out, and we get negative 10t squared equals negative 35. And now we have to divide both sides by negative 10. So the 10s on the left side will cancel each other out. So we get t squared equals, and on the right side we get 3.5. And now we can apply square root to both sides to change t squared to t. So the square root and the square cancel each other out, and we get t equals and square root of 3.5 is equal to 1.87. And the unit of time in this problem is hours. So that's the time at which the concentration will reach its maximum value. Now we have to check whether this indeed is the case, that this is a time at which the concentration is maximum. So for that, we can use the first derivative test. So as per the first derivative test, we check the sign of the slope of the tangent to the given function just to the left side and to the right side of the critical point. And if the sign of the tangent changes from sign of slope of tangent changes from positive to negative, that means the critical point represents a local maximum. So that means our answer is valid. So let's choose 2 points, to the one to the left and one to the right side of this critical point we just found. So we can use t equals 1.75 and t equals 2 for our first derivative test. So we'll find the sign of the slope of the tangent at these t values. So for that we'll use the expression for the derivative of the concentration function. So let's start with prime of c at 1.75. So we'll sub in t as 1.75 in the derivative expression. So negative 10 times 1.75 squared plus 35 over then 2 times 1.75 squared plus 7. Now we can start by simplifying the numerator expression. So negative 10 times 1.75 square is equal to, so I get prime of c at 1.75. So I got negative 30.625 plus 35 over, now in the denominator we have to do 2 times 1.75 square and then plus 7, which is equal to 13.125 square. Now if we analyze this expression, so we'll get a positive value in the numerator and a positive value in the denominator. So that means the slope of the tangent to the left side of the critical point is positive. Now we have to analyze the value to the right side of the critical point we found. So we'll sub in t as 2 in the derivative of the concentration function. So prime of c at 2 is equal to negative 10 times 2 squared plus 35 over 2 times 2 squared plus 7 and then square. Now we have to simplify this expression. So prime of c at 2. So in the numerator we get negative 10 times 2 squared. So 2 squared is 4. So we get negative 40 plus 35. And in the denominator, so 2 squared is 4 and 4 times 2 is 8 and 8 plus 7 is 15. So if we analyze this expression, we are getting a negative value in the numerator and a positive value in the denominator. So overall, the value will be negative. That means the slope of the tangent line to the right side of our critical point is negative. So if I have to visually explain it to you, so it's something like this. So this is the critical point we found, and this is the slope of the tangent to the left side of the critical point at t equals 1.75. So this is t equals 1.87, and then the point to the right side of this critical point here, so t equals 2. so the slope of the tangent is negative. So that's why the concentration can be considered to be as maximum at t equals 1.87 because it's a local maximum. So this should be the final answer for this problem, that the concentration reaches its maximum value at 1.87 hours. So these are the steps you have to keep in mind to solve a problem like this one. So it's very important to understand the first derivative test because that will help you figure out whether the critical point that you get, if it represents a maximum or a minimum value. So I hope you'll find this video useful. Please share it, like it, and subscribe to Homework Help. Thank you very much and have a nice day. Bye.